The U.S. Department of Defense spent $2 billion to develop the B-2 bomber. This aircraft was engineered to absorb and deflect high-frequency electromagnetic radar systems. We consider this massive machine the absolute pinnacle of human stealth technology. But millions of years before humans understood radar, a tiny mammal perfected this science. This is a 15-gram creature resting in the dense rainforests of Central America. What you are looking at is not just a simple green folded leaf. It is a highly engineered, mathematically precise, biological acoustic stealth baffle. It renders its tiny inhabitants completely invisible to advanced biological sonar systems. The master architect behind this structural miracle is the Honduran White Bat. To understand this mega project, we must analyze the complex botanical construction phase. The primary building material is a massive, living green heliconia leaf. This leaf is supported by a robust network of vascular water-pressurized veins. The Blueprint Atlas, Honduran White Bat, Acoustic Cloaking Engineer, Species Ectophylla alba, Acoustic Stealth Baffle Project. It cannot simply bend the leaf. It must modify the structural tissue directly. The bat executes a series of highly calculated surgical micro-incisions. It bites down on the lateral veins extending outward from the main midrib. The tiny builder applies exact, measured physical trauma to the leaf structure. If a human engineer attempted this delicate process on a modern suspension structure, this allows the deck to settle safely into a new, stable, balanced shape. The entire structure must survive without causing a catastrophic botanical failure. The specific angle of this structural collapse is not random or accidental. Pay very close attention to the complex topological geometry on your screen. Analyzing the biomechanics of the Honduran white bat and the acoustic properties of its modified leaf shelter. Observe. They establish an exact dihedral angle of 110 degrees. At this precise geometric configuration, the water-filled cellular matrix changes completely. It becomes a highly specialized, wave-absorbing, phase-canceling acoustic metamaterial. The Honduran white bat, an unexpected master of acoustic cloaking, utilizing its leaf to deflect and obscure its sonar signature. In a dimension. The bat's acoustic cloaking dampens the returning echo's signature. However, hiding behind a standard flat leaf creates a significant physical paradox. The predator's brain instantly recognizes this dense object hiding in the foliage. You cannot survive by simply breaking the visual line of sight.
To survive the relentless jungle night, you must become an acoustic ghost.
How does a tiny, bright white mammal defeat a biological radar system? The elegant solution lies in the 110-degree angle of the constructed tent. When the spectral bat emits a high-frequency sonar ping, waves hit the leaf. Because of the unique V-shape, the leaf acts as an acoustic deflector. Instead of reflecting the echo back, the angled walls scatter the waves. The sound waves are forced downward, absorbing into the soft forest floor. The military uses this exact geometric principle to design modern stealth fighter jets. Faceted surfaces scatter incoming radar waves completely away from the receiver. But the incredible engineering brilliance does not stop at external defense systems. Inside the shelter, these bats are stark, glowing, and completely white. Such bright coloration seems suicidal in a dark and dangerous jungle. Yet, sunlight filters through the green chlorophyll of the living leaf roof. This filtration creates a soft, green ambient illumination inside the tent. The Honduran White Bat. This species employs a unique form of acoustic cloaking. Furthermore, the interior concave shape functions beautifully as a parabolic reflector. When the bats communicate, their high-frequency whispers hit the curved ceiling. The sound is redirected inward, trapping their acoustic signature inside the bunker.
They have engineered a structure that is simultaneously a perfect cloaking device.
Furthermore, the interior concave shape functions beautifully as a parabolic reflector. But acoustic cloaking is only one form of incredible natural defense.
Deep at the bottom of the ocean, extreme conditions would crush submarines. There lies a creature that has literally mastered the science of metallurgy. It grows a permanent, bulletproof iron suit of armor from hydrothermal vents. Click the video on your screen to uncover the blueprint of the iron snail.